Hello, good morning. Hello, good morning.
Morning, sir. Morning, sir. Morning, sir. Good morning, sir.
Morning. Um, so we have 36 of you online. Well, I had planned this class to be a physical class, but I had an emergency meeting somewhere, and I'm still at the meeting. So I just quickly look for a space to deliver this lecture. It's all about the department. So we were looking at improving the facility in the classroom. So we had secured um, two smart interactive board, just as the one in the room 14. Room 14 is not our class. It's just an arrangement that we had with accounting. So our class is room 13, the two sides. So we had secured that, and power failure would be a major issue if a class is going on and there's a power failure. That will defeat the purpose of having that interactive board. So I was looking for our past MRM students for uh, donation of a solar system, at least to complement what we currently have. So I went for the meeting, and the meeting is dragging, and because there are also other developments. You must have read in the news the donation by custodian. That's 3-story building, to the department. Although the faculty will eventually assume, the structure, but it's being donated to the department. And I have to be proactive about how we can secure donation for the furniture in the building. So that's what has taken me away from the university today. So I hope you understand, why we're having the class online now. So I had planned that today will be our last class, and it will be a very long, physical interaction. But um, I'm sure we'll still finish. And if there's any need, we can still meet next week before I hand over to Resodala. So today we will be, looking at inference. But I want to take the inference from purely application angle, not just the formula and all the workings on the board. It's just to show us how we can use our Excel to carry out basic inference. So inference is about estimation based on sample. You want to estimate the population parameter. So it could be that you're about taking decision on investing on some securities, and you have historical data. So there have been an assumption that based on the expert advice, it's expected that each of the security will give you certain percentage in returns. So you might want to, validate that assertion using historical data, maybe recent historical data, for you to take your final decision. So that's what this inference is about. So you can estimate, arrive using point estimation or interval estimation. When you say point, you are using one single value as your estimate for the parameter. The parameter here could be the average returns, based on historical data. Okay, the parameter here could be the average risk. Maybe you are computing the coefficient of variation. So you want to know the risk, the returns relative to the risk. And so that's what we mean by parameter. Any function that represents the entire population. Those are academic jargons. So you might be interested in using just one single value. So you could say that the average return based on historical data, the average returns is 20%, just one single value. And it's also possible that you have a range. So you can say that the average returns is actually between 18% and 25%. So in that case, what you have used is the interval estimation. So you have used a bound, in which you expect the average returns to fall in. So you have the lower limit and the upper limit, that the average returns is between 18% and 25%. So anybody that falls in between, you still be taking as the same. So we could have that. That is estimation. You're just trying to calculate the value of the population parameter, because it might not be possible for you to have 100% information about that security that you are dealing with. So there might be some missingness or some restriction in access and so on. So you might have done some selection. You select at random from the pool of data that is available, and then you use any formula of your choice to compute the parameter of interest, be the mean, the standard deviation, the coefficient of variation, and so on. So you have used that information from your sample to generalize on the entire experience about that security, and that is inference. So you use parts of a population to generalize, so it's inference. So the other type of inference that you can have is actually testing the truthfulness of a claim, popularly known as hypothesis testing. The claim is, from this security, you expect the return to be 20%. And you wanted to test whether that assertion is true based on the fact that is before you. So and you just need to carry out a test. You calculate the mean, standard deviation, and then you compute what we call the test statistic, and then you use that to confirm or to determine whether the statement of 20% returns is valid, and you can rely on it. So that's hypothesis testing, and it's still part of inference, because you are using the sample data to generalize on the entire population. The population here is the security itself. So the sample that is just the data that you have got, from records about that security, and then you compute, and then you benchmark it with the 20% claim, and
Sir,
come up.
I'm not sure whether this slide is moving or maybe you are still just using this for this. The slide.
Hello?
I
The
said I'm
slide.
not
I've
sure.
not moved the slide. I'm just giving.
Okay, sir.
Yes, I'm just still giving us background to
Okay,
what
sir.
we want
Okay,
to do
sir.
today. I have not started moving the slide. I've not started doing anything. But I hope you are hearing me clearly.
Sure, sir. Yes, sir.
Okay, so I'll just give this background on inference. What inference is and how important inference is. So generally, it's about using information from sample to take a vital decision, rather than using the entire information in the database, that you can just take sample and what you have will be your valid decision at the end of the day. So that's inference. And inference starts with sampling. Take a little part of that information that you have, because you might not have the resources, you might not have the time to study the entire database before taking a decision. So you need to take, that quick decision, and sample will be the best, for you to deal with. So how do you take the sample? You guys have done sampling before. Can use probability based, can use non-probability based, and so on. So once you have taken that sample, you observe it, do all sorts of calculation, and whatever you have, you will not just say that it is the sample, that is giving you that. You will just generalize on the entire database, and what you have at the end of the day, it's still inference. Okay, so our regression analysis, our correlation analysis, they are all inference. They are all inferential statistics. Okay, time series, and so, because you are interested in understanding the behavior of that variable over time, or the behavior currently, and so on. So for you to take that decision about the behavior, you need information. And rather than, because of restriction and because of lack of access, you might rely on sample information, sample data to take that decision. So, and that's where sampling comes in. And then the data, the information that you have from your sample will now be generalized on the entire data. So, and that is inference. So today we will be looking at sampling. I'll just show us how to select in case you have a pool and you just want to select at random, and you want to select at regular interval, that's systematic. I'll just show us how to do it in our Excel, because you need to implement at this level. We are not learning the basic concept. You know it. And then we will now move to testing our hypothesis, starting with one sample test. Okay, so how do you carry out your z-test or your t-test? One sample test. So from there, we will extend it to two samples. You have two different securities that are behaving almost in the same way, but you want to empirically compare them in terms of their returns or in terms of other things beyond just looking at some fundamentals, that you can easily determine. So how do you test two samples? And what if you have more than one sample, more than two samples? I have 3 securities, 4, 5 securities, and there has been a claim that they are equally, performing in terms of their returns. You have assessed the risk level, but the risk level suggests that on the average they are the same. So how do you now empirically, test whether indeed they are equal in terms of returns or in terms of other things? So we will do that today. So we start with sample. So what I have here was actually downloaded from Yahoo Finance. I had removed the name of the stocks, and I have the returns of this stock for I think for 20 days. So let me just check. So I'll put the days and okay, for 18 days. So, and so I'll be using this for my teaching. So I'll start with sampling. Okay. So from the whole lot of the database, I know studying everything might not be feasible. So I can just select. If I want to select at random, I don't want it to be subjective. If my selection were to be subjective, I could say most recent data, okay, most recent experience. So I could select the most recent 20 days, the most recent 50 days or 100 days, and then I use that for my study. So that selection is non-probability. I have not used any random techniques in selection. I just use the purposive sampling technique. I've chosen the number of days and I went in the database and then I do my selection. So we'll start with the random sampling technique. So the random sampling technique you can get from your add-ins. Remember what we did in our first semester. So the add-ins you can get under your data from here. I'm sure nobody has any issue. So sampling, you select your sample. Sampling is part of the options, available available tools, and it's embedded, in your Excel. So I'll select sampling. There are other options that are available. And analysis of variance will, of course, today I will just show us how to use it when we are testing hypothesis under more than 2 sample tests. Correlation analysis is there, covariance, descriptive, exponential smoothing, can do your histogram, moving average, can generate random numbers, can do regression, can do sampling, t-test, all the tests that we'll be dealing with, they are all there. So all we'll be doing is just to follow instructions and implement. That's what we'll be doing today. So, and now I want to sample. So we want to select, okay? So I want to select from my available data. So I want Excel to do the selection, okay? So I'll select sampling, and by default, this is what you will have when you land on the page. This is the pane that will prop up for sampling. So the input range there is just the identifier of the units in the population. So let me use the days as the identifier, so that if day one is chosen, that means the returns on day one will be selected as part of my sample to use in my computation. If day 6 is chosen, then I will select the returns that correspond to day 6 and so on. So that's the input range. So it is not the actual returns that you will put in there, or maybe there are names. It's not the names that you put in there. It is the identifier. And those identifiers have to be whole number, but that's how Excel is designed. So I can select my my days. So the days are my unique identifier. So I select that. Label, because I've chosen that title, the heading, okay, as part of the data. So I just want the system to know that days is not part of the data. Data starts from 1. So I can just say that the label is the first data. So how many samples do I want? So I can say, indicate how many samples. Maybe I want a sample of size 5. Okay, if 5 is okay for me, so I can just put 5 there. All right, and then where do I want the result to be? By default, the system will create an additional sheet. So if you look at the screen, I have sheet 1. By default, it will just create additional sheet and then put the results there. So I will do that, then I will repeat it and see how I can display my results on the same page or on the same sheet where the original data is. But by default, it will go for the new worksheet apply. So yeah, this is all I need, the information that I need for my sampling. I want to select out of these 18 that I have. I don't have resources to study all, or I can just use my Excel to select the sample. So if you click on that, okay, so you can see on the screen I have just one sheet. So once I click OK, an additional sheet will be created as sheet 2. So you can see sheet 2 have been created. So I've selected my sample, and that means serial number 1, the returns on day 1 will be selected for the study. The return on day 5 will be selected for the study. The return on day 16 will be selected. The return on day 12 will be selected. The returns on day 15 will also be selected. And that is what I will use in my computation. Now let's, I can copy the return on day 1. So let's assume that I'm studying stock. Okay, let me just study everything. The return on day 1, okay, selected. Then return on day 5. So I'll go and select day 5. The return on day 16 is selected. The return on day 12 selected. The return on day 15 is also selected. All right. So I've done my selection. So I have my sample now. Okay. So the next is for you to now do um, your estimation. Right. So can estimate. I can just run some basic descriptive in my data. Okay. And then I have all the information. So if I want to run my descriptive on the data so that I have some information, so you just click on select descriptive, okay? Data that I've selected. Of course, the label is in the first row. All this stock 1, stock 2, stock 3, they are all labels. They are not part of the data. So I can, where do I want my data? I want it to be, here on the same page. And then the summary statistics will be there. And then I can have my other details. So, and what you have there will be your, your estimates. Estimate about the mean for stock 1, the mean for stock 2, and so on. So you have the standard deviation, and you can have all of those. So that is when you select and you want it to be displayed in another sheet. Now let's go back to the original data. Let us see how we can just display it on the same sheet where our original data is. So you can do that, So again, let's just go through the process. It's sampling that we want, right? We want to select. This time around, remember, we are executing simple random sampling. We are selecting at random, purely at random. And the selection is actually with replacement. That means an object can be selected more than once. The unit can be selected more than once. That means once you select it, you observe it, you can return it back into the population before you select another one. So now let's have that. So we want to select the label. Remember, it is the identifier. That's what SDL does. It doesn't select the names or select the observations. It is the label, that you have attached to it that you will use. Yeah, the identifier, and those identifiers have to be whole numbers. So, is there? But this time around, I want it to be in a location. Okay, so which location do I want? Now let's determine. So I want it to be on H. So I'll just go to H and click. That's all. Now let me repeat it again. So I want it to be on H. Okay. So I'll just click in this box. Then I'll locate where H is. Then I'll click. So that means it will start displaying from that point. Okay, that's the essence. So that's all that we need, and then we have our sample. So you can see stock 16 on the 16th day is choosing, 11th day, 16th day is choosing again because it is sampling with replacement. Okay, then 9 and the 14. All of these put together will be your selected sample. And then once you select, you now take it further and continue your computation. So inference starts with sampling. Okay, you want to make a inference. So even if you have a production line and you want to assess the effectiveness of your machine with respect to the number of rejects, that you are experiencing. So you don't need to study or observe everything that you have produced from that machine. It is still sample that you will select. You produce biscuits, you select sample of biscuits. It is those sample that you take to the lab or your quality assurance unit or quality control unit, and then you start observing the parameters of the selected biscuit. So you check the breaking strength, the water content, the taste, and so on. So, and whatever you observe from the sample, you now generalize on the entire batch of biscuits that you have produced. So that is where it starts. It starts from that sample of biscuits that you have selected. Okay? So even if you do pure water business, or let's say bottled water business, and you are concerned about the waste, that is being generated, from the production line with respect to leakages, no customer will want to buy bagged water that is leaking. All right, or even when it is bottled water and the bottle is leaking somewhere, they will constitute waste. So you are concerned about it, and you wanted to know what proportion of your products are actually wasted, because you are putting some man hour, you are putting some resources in producing it. So you don't have to observe the whole production of 1 million bottles that you have produced. You only need to take a sample. And that's where it starts. That all decisions start with that small part of the entire, and then you observe it, make your readings, and then you generalize. That's it. So how do you select this small part? That's why we are starting with this sampling. Okay, so you can select it. That is, if you already have the database, you can just pull it using this tool that Azure has. Select, and then it is what you have selected that you will locate, and then you observe. So is that about the sampling? The sampling that we have done now, it is sampling using simple random sampling. You give every unit equal chance of being selected. So you can see from the first selection, the numbers, spread across number 1, number 5, number 16, 12, and 15. You see, when I did the second selection, you can see number 16, 11, so yeah, selected at random. Now let us do another type of selection using the systematic sampling or periodic. That means you select at regular interval. You could just say at 5 interval. That means you select the 5th one, the 10th one, the 15th, and then so on. So it means once you know the first, you can easily get the rest, because after all, you are selecting at interval. So let's just see how we can do that using our Excel. Please feel free to ask question. Please feel free to ask a question. So Now let's do the selection. Meanwhile, I hope you have seen your results. You know, I had to look at it again, you know, and I think what you have there is fair. All right, so we want to do sampling this time around systematically. So rather than choosing the option of random, okay, we go to period, which is the period now. This time around, you select at the period, at the interval of, so if I want to select at interval of 3, that means I will select the 3rd observation, then I keep adding 3. The 6th observation, the 9th, the 12th, 15th, and so on. Okay, so then where do I want the result, you know, to be displayed? So so let's create a new sheet so that I don't mess up this data because we need it for other things. So let's put it on let's just come out on a new sheet. So I expect sheet 3, you know, to be created, and that sheet 3 will have my selected, the identifier of the selected sample using systematic sampling. So I expect the result to be 3, 6, 9, 12, and so on. That's what I expect. So, but let's just see what the system will bring. And I click my OK. So you can see that's the result. In sheet 3, 3, 6, 9, 12, 15, and 18. So that's the idea behind systematic sampling. You select at regular interval. You're not just selecting at random. There's no pattern in the simple random sampling that we did earlier. The number were just coming all over the places. But here, you have your data coming up in a definite pattern. First one is 3, the next one is 6, 9, 12, 15, and 18. And what it simply means, so if I go back to the sheet where my data is, it simply means that the data corresponding to day 3 will be selected as part of my sample, day 6 will be selected as part of my sample, day 9, day 12, 15, and 18. Okay, so that's how you do your selection. And once you do the selection, you just go ahead and compute whatever you are interested in. Okay, so that's how to select systematically. So that's the option for the selection. Okay, so we are done with sampling. And let's now go to hypothesis testing itself. Okay, so we now want to test. What is hypothesis testing? An hypothesis is a guess or a conjecture about the value of the unknown population parameter. So it simply means a statement that needed to be verified. Okay, that's the meaning. You needed to test the truthfulness of that statement based on the available information. So, and our hypothesis can be 2 types. We have what we call the null hypothesis and the alternative hypothesis. So the null hypothesis is actually the hypothesis of primary interest. It is that hypothesis that you want to accept or reject. So there have been a claim that, or there's a suggestion is that, look, this security that I'm introducing to you have been yielding 15% on the average for the past 18 months. On the average. Okay. So you might want to verify that statement. The process of verification is hypothesis testing. So you have looked at that 15%, or you consider it as a guess, as a conjecture, as a claim that needed to be tested, a claim that needed to be verified, a claim that its truthfulness needed to be checked. And you have to base your decision on data, on sample data. So the null hypothesis, that hypothesis that you want to accept or reject. So that 15% that whoever is advising you had made is the null hypothesis. It is the primary hypothesis. It is that hypothesis that you either want to accept or reject. While the alternative hypothesis is the one that gives you the direction, in search of the truth, in case you have rejected the null hypothesis. So it gives you the direction to follow in search of the true value, in search of the true returns. Okay? Once that claim have been, rejected based on the facts before you. So he had claims 15%, and the information that you have suggested otherwise. So the next question is, okay, what exactly or what range is the return? So you can either be looking at values that are higher than 15%, values that are lower than it, or so those are the possibilities. So the alternative is the one that gives you the direction to go when the null have been rejected. So so usually if you are to be doing this manually, you need a formula that you will use in to calculate. You now have what they call the calculated value, and then you go to the table, you go and extract, and then you have what we call the tabulated value, and then you now compare the two. If the calculated value is higher than the tabulated value, you will say that the hypothesis is rejected, or you say that it is significant. Otherwise, you will say it is not significant. That formula that's used in calculating, in quote, that calculated value, that formula is called the test statistic. A test statistic. So, as part of the earlier definition, I said a statistic is a function of sample value, while a test statistic is a function of sample value whose magnitude will now determine whether an hypothesis will be accepted or rejected, because it is the sample, it is the formula that is used to test the hypothesis. So that formula is test statistic, and we defined it as a function of sample value whose magnitude determines the acceptance or rejection of the null hypothesis. So all of those, you will put together in calculating your value. But here, we're interested in taking decision using basic tools that are available. So the formula are in the table for you, sorry, in the slides for you to play around with and familiarize yourself with it. But my own interest is for you to use available tools to take your decision. Although some of us might be analog, you still want to use your calculator and use those formula. You are free to do that if you have the time. All right, so let's see how we can test our. So we'll start with one sample test, and I need to type this on the screen. So one sample test. I will share this Excel sheet later. So the one sample test I want to test is there have been a claim that the average return is for stock one is 10%. Okay, 10%. So so test the hypothesis that the average return from the 5 securities are more than 10%. Okay. So for the two sample tests, you are actually, okay, let me explain the one sample test. You see, if you had to study just one single population and you want to confirm or you want to test the validity of some claim, and your sample is from just one single population for the test. That's a one sample test. Okay, the sample is from just one population only. Now, under the two sample test, it's basically meant for comparison. I have two securities and I wanted to take decision. So, I might want to test whether the two of them are equally performing, one is less than the other, or one is greater than the other. So, and that will require you collecting information from the two different securities. So, your sample is from two different populations, and that's two sample tests. Because I will have sample one from the population of maybe security one or stock one. I'll also have another sample from stock two, and then I do my comparison, or I do my test, and so that is two sample tests. All right, so I will just say that test the hypothesis that the following pairs of stocks are equally performing in terms of returns. Okay, so the pairs are stock one versus stock two, stock. Maybe I'll just say stock three versus stock two, stock four versus stock one, right? So let's leave it that way. So, and then three or more sample tests, 3 or more sample test. So under the 3 or more sample test, the test is about several populations. I have 3 stocks, and I want to test if the 3 of them are equally performing. I have 3 different marketers, and they meet target at different time, or you have figures about their performance, maybe in terms of new accounts, or balancing the account of the customer that they manage, and so on. So you have the information over time, and you want to take a decision. You want to maybe promote just one of them because you don't have resources for the 3 of them, at the same time. If you promote them, all at once, and you wanted to test whether they are equally performing. On the surface, you might just say, oh, let me calculate the mean, and then I look at the average. The one with the highest average will be promoted. But you might be making a mistake, because the risk variability is also very important. So if you have one of the marketer that is always bringing 20 million, 20 million, 22 million on a monthly basis, let's assume that 20 million is sufficient. So it's bringing between 19, 20, 22, and so on, and it's consistent. The variance there will be very, very small. And then you have another marketer. Sometimes it brings 0, and then you can have 100 million, 50 million, 0, 0, 10 million. And then at the end of the day, you computed the average. The average is 23 million. While the other one that is consistent, okay, that one brings in 21 million. So if you had used just mere average, take your decision without putting into consideration the erratic, behavior, you will have promoted the one that is very erratic, and left out the one that is consistent and is bringing in something that is still considerable. So that's what this test will do. It won't just look at the mean alone. It has to be the mean with respect to the variance. So it will put in the risk along with it. So analysis of variance, or popularly known as ANOVA, is what we will use in this test. And it's mostly based on variance. It is variance that is being tested. For one sample test, it is the mean that you are calculating and you are comparing. For 2 sample tests, it is the mean of the first, the mean of the second, and then you make a comparison. But for 3 or more sample tests, it's actually the variance. It is a ratio of the variance that is being used to carry out this test. Ratio of 2 variance is F distributed. Okay, they follow F distribution. So don't bother about that, but it's just giving information from first principle. So for this, I want to test whether or not. So I can say test the hypothesis that One, stock. One, 2, and 3 are equally performing. Then test the hypothesis that stock 3, 4, 5. Let me use 3, 4, 5 now. Stock 3, 4, 5 are equally performing. And in fact, test the hypothesis that the whole 5 perform equally. Test the hypothesis that the stocks 1, 2, 3, 4, and 5 are equally performing. Okay. So now let's go through one after the other. So the first one is the one sample. How do you carry out one sample test in an Excel environment? Okay, so I will so for all the questions that I have on the screen, I will only do the first. So you guys will do the second and third, or for each of them. So at least you can. Or what do you think?
No problem, sir.
It's okay,
All right.
sir.
Okay, thanks. So now let's do our test, the one sample test. What we'll be using for the one sample test is the p-value. I'm sure this is not the first time you guys are hearing p-value. So when the p-value is less than 0.05, the test is significant. And once it's significant, we're going to reject the null hypothesis. Otherwise, if the p-value is not less than 0.05, then the hypothesis stands. So now let's start.
Sir, come again, sir.
So I said we'll be making use of the p-value, for our decision under each of the tests. That if you are testing at 95% confidence level, if the p-value is less than 0.05, the hypothesis is considered to be significant. And that means the hypothesis will be rejected. But if it is not less than 0.05, then the hypothesis will be accepted. So now let's look at one sample test. So I will okay. I want to create space. Let me put this here. Okay. So I'll start here. So one sample. So I'm going to make use of the z-test. Just type equal to. Okay, then you type z. Once you type z, the test, you will have that option. The z-test will pop up. All right, so, and it says it returns p-value, just like I said, it will return just one single data point. Once that single data point is less than 0.05, the test is significant. Otherwise, the test is not significant. So, I hope that is clear. So I'll just select my Z test. So if you look at the question, it says we should test for 10%. So I'm looking at 10. So that means the test value is 10. So the array, this is the array. The array simply sorry, my network went bad. So I have to start this process again. Let's start it again so that nobody missed anything. So I'm dealing with stock one now. Let me just put stock one. So to test the hypothesis, once I type equal to, of course, the function will be activated. And I put Z, I want to carry out the one sample test, okay? One sample test. So once I type Z, you will have the Z test function coming up. So I'll select, just double click. The array there is the sample data. The X there is the value that you are testing against. That claim that someone has made, that claim that your consultant has suggested, that claim that you want to confirm its truthfulness, okay? So my array for stock one, I'll just select, okay? Comma, then the 10, because I'm testing against 10. All right? And then I'll select. So you can see that the value, let me make it to more than one whole number so that it won't look as if it's that's shit. So it's exactly 1, and that means it is higher than 0.05, and that means the test will not be rejected. And what it means is that on the average, your return is not higher than 10%. That's what it means. Okay, for 2 sample tests. So I'll start with stock 1 and stock 2. So that means I want to check whether the 2 of them are equally performing, on the average. So this time around, you are not testing against a number, whether they are the 10% or not. You are just saying that, look, these 2 securities on the average, are they equally performing? Putting into consideration the average and the risk, okay? The variance, the standard deviation, and so on. So I will use my my add-ins of 2 sample tests. You can see it. The Z test, 2 sample. Can you see it? So I can just select. Now, the difference between the Z and the T is that For the Z, it means that you have information about their variance, population variance, which we don't have. I don't have any extra information. I just have this sample selected, from that population. Remember, I said I downloaded this from the Yahoo Finance platform. So I don't have detail about the population standard deviation. So I will not be able to make use of the Z. Well, if I do have, because in the let's select the option so that you understand what I mean. So you will see that the input range of the first, that means the data for the first sample or for the first stock, the data for the second stock will be entered under variable 2. Now, the variance that is known, I will now have to put the value because it is required. But I don't have that information, so there's no need for me to make use of that option. So I will do 2 sample, but this time around, I will do t-test. So I don't want to assume that they have equal variance. Okay, let me, all stock, they are independent of the other. So I will select my t-test for one sample. Why am I selecting t-test? Because I don't have information about the variance. So it will calculate variance by itself. Otherwise, if I choose the z-test, that means I have information about the variance. It will use the variance that I supply in the calculation. That's the difference. So I don't have that information. I'll just leave it at that. And then I do my selection. Okay. Now, remember I'm comparing stock 1 and stock 2. So input range for variable 1 for stock 1. All right. So I will select stock 1. And then for stock 2, I will also select. You will notice that I'm highlighting from the label itself. So that's why I will select label. Now, so if I'm testing that they are the same, it simply means that I'm assuming that the difference is 0. That's the meaning. So if I'm saying that the mean is 5, I'm saying that variable 1 is higher than variable 2. But that's when you can have a whole number, a positive number as the mean difference. If I say the mean is -5, so I'm saying that variable 1 is less than variable 2, and you expect the difference to be 5, although in the negative direction. But here we want to test whether they are equal or not. So that means we are selecting 0, because it is when the difference is 0 that we say that they are equal. All right. So I don't want my original data, to be tampered with. I want a new sheet to be created so that I can always manipulate in that sheet. So I will leave it at new worksheet apply. Okay, new worksheet apply. So if I click on okay, so a new sheet has been created. All right. So you can see now for stock 1 and stock 2. You see the variances have been computed by itself and so on. And then look at the p-value. Look at the p-value. The p-value is less than 0.05 here if it is a one-tail test. One-tail simply means you just want to select whether the it means that the direction of the alternative hypothesis is either less than or greater than. Okay. When you have it as not equal to, that's when the test will be a two-tail test. Two-tail test. So the test statistic that you see there, that means the formula, that formula. You might not like the way the formula looks like, but the value that you get from that formula is what is 1.98. Okay. The critical value is the value that you obtain from table, 1.71. So you can see that if it's a one-tail test, the value that you calculate is higher than the value from table. And that explains why the p-value is less than 0.05. That means the test is significant. All right. But if it's a two-tail test, the value that you calculate, okay, is not more than the value from table. Because the value from the calculate is 1.9. Value from table is 2.007. It's not higher. And in this case, you will want to accept. Okay. So if it's a one-tail test, you will say that they are actually different. But if it's a two-tail test, which is what we want to do, because it's actually a two-tail test, because you are testing that they are not equal. Not equal to is a two-tail test. If it's a one-tail, that means you want to assume that the alternative that says that the stock 1 performs higher than stock 2 as the alternative. So in this case, the test of not equal to will be rejected. But if it's a test that stock 1 performs higher than stock 2, then that test will not be. So you can see it there. Look at the average. Stock 1, the average is 0.05. That's about 5%. Stock 2 is 3%. But look at the variance. You will see that stock 1 has a higher variance as compared to stock 2. So indeed, if it is a one sample test, then that as the result that they are different is valid, because they're not actually the same. You know. So that's how to carry out hypothesis testing for two sample tests. Now let's look at three or more now. Three or more sample tests. So I want to do for stock. One, two, three. That means I want to tell whether the three of them are equally performing in terms of the returns. Whether the three of them are equally performing in terms of the returns. So I will go back to my data analysis. The tool that you will use is analysis of variance, ANOVA, one sample or single factor. So I will select and then the input range. The input range now will now be the entire three at the same time. I will just select the three of them at the same time. Okay? And then I have my label in first row, because the stock 1, stock 2, stock 3 labels, they are not part of the data. I just want the system to know. And it's as simple as that. No other thing to add. Yes, I will prefer the new worksheet plus. That means another sheet will be created so that I don't mess up my data page, sheet 1. I just click OK, and then I have the results. So you can see, for stock 1, we have 18 data points, for stock 2, for stock 3. These are the averages, okay? These are the variances. And then, remember I said we are going to make use of the p-value. So you can see that this p-value is less than 0.05, because this is to 10 to the power of -8. It's actually 0.0000000233056. That's what it means. 64700. That's what it means. 0.0000 in 8 places. You now have 647. That's why we have this as your p-value. So it is very, very significant. They are not the same in any way. Okay, that's what this text is saying, that the 3 of them are not the same. So if they are not the same, which one gives the highest returns? It is stock 1, followed by stock 2. Stock 3 has the least returns. You can see it. In fact, it is 0.4%. Not even 4%, it is 0.4% returns. Okay? And this is how the test is performed. So, ladies and gentlemen, that's the story around inference that we want you to understand. So, we start with sampling. So, what's the essence of sampling? Sampling is for you to take sample from a population so that you can make inference. When it is very expensive to study the entire population, when it is not feasible to study the entire population, sampling becomes, sampling comes handy. And your sampling can be based on probability, chance mechanism, random techniques, and it can be subjective based on some rule of the thumb and so on. So under the probability sampling, you can have your simple random, stratified, and all the rest. And under the non-probability, you can have convenient, purposive, quota, and the rest. So once you have taken your sample, the next is for you to estimate. You go ahead and carry out some calculations. What you have will now be a representation of the entire population. So you wouldn't say that, oh, what I calculate is for this sample alone. No, you're just saying, I think the average for the population is whatever you have. So that's the sample. And you might still go ahead and do your estimation based on point or interval. That if you use one single value as the approximate for the population parameter, then that is point estimation. Point. Otherwise, if I use an interval, if I use a range of value, then that would be interval estimation. Yes, Ayo Akpankpa, go ahead.
But could you please just explain to us the alpha that was used during the calculations? How is alpha used and what is it? Just a brief explanation. You might have done that earlier on. Apologies, I didn't catch it.
Okay.
Thank
you.
So,
thank you for the question. The test, as we carried out all through, based on 95% confidence level. So we are leaving an error margin of 5%, which is standard that unless expressly stated, you assume that your test is on 95%. And that's why you will see that, let me quickly click on the test again, you will see that for each of these tests, you will always see the alpha there, 0.05. It's assumed unless I change it to something else. So I can also, even for the two sample tests, and that's for the two sample tests that I did, the t-test. So if we click on it, you will see that the alpha 2 is also set at 0.05. Now, what does the alpha mean? The alpha means the definition of that alpha is actually level of significance. It is the maximum probability that you will reject a true hypothesis. Because while taking the decision, you are liable to two types of risk. It is possible that you reject a true statement, a true claim, and it is possible that you accept a false claim. So the probability that you will reject a true claim is called the level of significance, and that's where the alpha is. So if you set it at 5%, it means that 5 out of 100 times that you carry out this kind of test, you are likely to have rejected a statement that was true. So that's I hope I'm able to.
Yes, you did. In summary, can we just say that it is a default setting unless expressly told otherwise?
Exactly. It is set as default. Each time you open, you will see that it's set as 5%. Yes.
Unless it's expressly stated otherwise. Thank you very much.
So, okay, Wilson.
Yes, sir. Good morning, sir.
Yeah, morning. Well done.
Yeah, so I want to go back to the two sample tests, sir.
Yes.
Step 1 and step 2.
Yes.
You know, for the step 1, you made mention that we don't have a variance yet. That was why we used the two sample assuming unequal variance.
Yes.
Yeah, so I want to ask, if we have the variance, how can we play around it in the add-in?
Oh, okay. So for the okay, so let's choose the option that will allow you to type in the variances. So if you have the variance, you are going to make use of the Z because you already have it. You have it. So you make use of the Z, and then see the options are there for you to plug in the variance for the first and the variance of the second. So you can actually use it, but it will come within the Z test. I hope it's clear.
All right, sir. Yes, sir.
So, ladies and gentlemen, I will allow you to continue to enjoy yourself. We'll stop the class here. Maybe we'll just have a physical class just to have a recap of everything that we have done. And then possibly, maybe I'll come with a past question. And then let's see if we can look at it together. But if you don't want it, there's no problem. I don't like stressing students. And of course, my assignment is coming soon. So I'll put all of this together, give you an idea, and then give you my assignment, which I will advise that you submit a day, you submit on your exam day. Yeah, you submit on the exam day. So please, I might not tolerate the late submission, you know, as I did in the first semester. So, yeah. So should we have a test?
Babu.
Sir, let's.
I think the assignment is perfect.
The assignment is better.
The assignment is perfect.
Assignment will be fine, sir.
Assignment is preparing.
Yes, sir. Yes, sir.
All right. So, All right. So I wish you a happy weekend. Bye-bye.
Thank you, sir.
Thank you, sir. Bye-bye, sir.